hopefully you know the difference between scalars and vectors. To reiterate, a scalar quantity is a quantity that has a magnitude in SI units. It's a quantity that you can measure, and the magnitude tells you the size of the quantity, and the SI unit tells you what type of quantity you're talking about. And a vector quantity is a scalar quantity with a direction. Okay, so you have an additional property, an additional characteristic that is the direction. And when something has a direction, we call it a vector quantity. Okay, now I'm going to write down a few physical quantities, scalars on the left side and vectors on the right side, to make it easier to comprehend. The first two that I'm going to talk about are distance and displacement. Okay, let's say that this is your house and here's your school. So you go from your house to the school, and maybe the path from your house to school is this curvy path drawn with white pen, okay? So this total length that you will cover to move from your house to the school is your distance, okay? So the total length covered by a moving object, regardless of its direction, is the distance, okay? If you could see, the direction is changing at every point, right? So if you were here, you're going like that. 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 And so on. So if I were to tell you one direction to go from your house to the school, I wouldn't be able to tell you if we were following this curvy path, right? But if I told you that there is a short distance from your house to the school, and if let's reword our idea. Or firstly, let me complete the concept of distance before I move on to displacement. So this total length covered by a moving object, regardless of its direction, is the distance. Okay, I'll write that definition here, and I want you to take a few seconds, absorb those words, and make sure you're comfortable with the wording before we move on to the next idea. The total length covered by a moving object regardless of its direction. Okay. Now, if I drew a line from your house to the school, like a straight line, and I'm drawing an arrowhead to tell you the direction that you have to go in this direction. It's one single direction, and it's the shortest length between these 2 points. That is your displacement. Displacement is the shortest length from your house to the school in a straight line. Okay, so your house was the start position, and the school is the ending point of your journey. So we could say that displacement is the length or the shortest length from your start point to the end point in a straight line. Being in a straight line is helpful because it can tell you a single direction, okay? So we'll write down that displacement is the shortest length from the start point to the end point in a straight line. Now, why is it a straight line? Because that is the way that firstly you'll be able to get the shortest length, and secondly, if it's in a straight line, only then can I give you a single direction. Okay? Alright. Now, since both of these are lengths, like distance is also a length and displacement is also a length, the standard unit of both of these is a meter. Okay? So the SI unit is meter for this. Oops. And the same for displacement. I hope everything's clear here. Now, one more point that I want you to remember is that if you look at this situation where the original path was curvy and the displacement is your imaginary path from point A to point B, why do I call it imaginary? Because, okay, let's think of it this way. When you go somewhere, unless it's a highway or you're lucky, you're probably going to have to take turns and like change your path several times and then get to your destination, right? Maybe there is a forest here or a water body, something, so they couldn't possibly make a straight path, right? So the constructors possibly have made a path that looks like this, or this, or this, I don't know. Okay, so this path that you're following is your total length that you're covering to go from A to B, and it's the distance. And it's a curvy path, right? That means that your curvy path, the length of your distance, okay, or sorry, your distance is greater than your displacement. Okay, so since it's not a straight line, this one is definitely more than the blue line. Okay, so I'll just write this point here, that distance is always greater than displacement. I do have an additional point to make here. Let's say that this is your start point A and this is your end point of the journey B, and the person finds a straight road, let's say a highway. Okay? Now, in this case, the car is moving from A to B on that straight road. Now, the total length that the car is covering is a straight line. Okay, so that is the distance. And the displacement is definitely a straight line from A to B as well. In this specific condition or situation, your distance is equal to your displacement, right? Since it's a straight road, the person will cover this distance from A to B, and if you were to extend a straight line from A to B, that is the same as your white line, which was the distance. So in certain situations, specifically a situation in which you have a straight path that you're covering, your distance is equal to displacement. So I'll just add a little line here at the bottom to represent that distance is either greater than or equal to displacement. Distance is never less than displacement. Okay? Let's revise this concept because I want to add another concept here that is the shortest length from your start point to your end point in a straight line. What if I had something like this? So let's say this is point A and the track is circular. Okay. All right, let's say we have a circular track and a car is traveling on this track. The car started its journey at A and then it traveled all the way on this track and reached point A again. So its start point was point A and it ended its journey at point B. Okay? In that case, your start point, here, I'm just going to write it down. Your start point is A, and your end point is also A. So it's a single point. Now, you cannot draw a line between, like, you cannot draw a line when you have a single point. A line is possible to be drawn when you have at least 2 points that you can connect. If it's a single point, you cannot draw a line, right? In such situations, specifically in circular motion, what happens is that your displacement is 0. Not necessarily circular motion, in any motion where a moving object returns to its starting point or its original position, your displacement is equal to 0. Now, what is the distance? It's the circumference or the total length of this circle. Okay? If you're given a circle and you know the radius of the circle, which is the length from the center of the circle to the boundary, we call it the radius, then you can find the distance by equating it to the circumference of the circle, which is equal to 2 pi into the radius r. So if you know the value of r, plug in r and find out your distance. Okay? All right. Recap. Distance is the total length from the start to the end point, and displacement is the shortest length from the start to the end point in a straight line. Since we cannot draw a straight line on a single point, we say that displacement is 0. So in circular motions, or motions where your start point and end point is the same, the displacement is 0, but your distance is the total length that is covered.